All right, so today we're going to do a deep dive into something I think you'll find pretty fascinating.
Okay.
It's something that we all see every day, but probably don't give a whole lot of thought to
Yeah.
fire hydrants. Those
Ah,
brightly colored things sticking out of the sidewalk.
right.
We're basing our deep dive today on a YouTube video,
Okay.
and it's from the channel Concerning Reality,
All right.
aptly titled, How Do Fire Hydrants Work?
Hmm.
So are you ready to learn more than you ever thought you needed to know about fire hydrants?
I am ready.
Because I know I am.
I think you'll be surprised by what we uncover about fire hydrants.
Okay.
They're a lot more than just simple valves. They're
Okay.
actually meticulously engineered pieces of equipment that play a vital role in public safety.
Okay, I'm all ears.
Right.
To be honest, I always thought fire hydrants somehow pump the water themselves.
Okay.
That's not how it works, is it?
That's a common misconception. The magic really lies in the water pressure that's already present in the pipes beneath our streets.
Oh.
Um, think of it like this.
Okay.
You have a water balloon,
Right.
and it's already inflated and just waiting to be released.
I see.
The fire hydrant is simply the gateway that allows firefighters to tap into that pressurized water supply.
Oh, so it's the water pressure that gives those fire hoses their impressive power,
Yeah.
not the hydrant itself.
Exactly.
Okay.
And that pressure can vary depending on the location
Right.
and the size of the water mains.
Right.
In areas with a higher risk of large fires,
Okay.
like crowded downtown areas
Right.
or industrial zones,
Sure.
you'll find hydrants that can unleash a torrent of water.
Okay.
We're talking thousands of gallons per minute.
Thousands of gallons a minute.
Yes.
Wow, that's enough to fill up a swimming pool in just a few minutes.
It is.
No wonder firefighters can knock down those massive flames so quickly.
It's really quite impressive.
Yeah.
Imagine a warehouse fire where every second counts. Those high-flow hydrants can make the difference between containing a blaze and a catastrophic event.
Right.
It's all about having enough water on hand to tackle any situation.
Okay.
Yeah.
That makes sense.
Yeah.
But wouldn't using that much water cause the pressure to drop in nearby homes and businesses?
That's a great question, and it's something that engineers have carefully considered.
Okay.
The water system is designed with pressure-regulating valves
Okay.
that act like traffic cops, directing the flow
Okay.
and ensuring that everyone gets the water they need, even when a hydrant is in use.
So it's a balancing act,
It is.
making sure there's enough pressure for firefighting while keeping the water flowing for everyone else.
Correct.
That's impressive.
Yeah.
Okay, so we've got these pressurized pipes underground, and the hydrant acts as a release valve.
Yep.
But I've noticed that fire hydrants come in a variety of colors.
Yes, they do.
Is there a reason for that, or is it just for aesthetics?
There's definitely a reason.
Yep.
It's not just about looking pretty. The color of a fire hydrant actually tells you a lot about its water source and purpose.
Oh, really?
Yeah, it's like a secret code embedded in our urban landscape.
Okay, I am officially intrigued.
Okay.
Spill the tea on this color-coded system.
All right, so the most common color you'll see is white,
Okay.
which indicates a standard public system hydrant.
Right.
Then you have yellow, which signifies a hydrant connected to a public water main.
Okay, so white and yellow are both connected to the public water supply.
Yes,
But there's a subtle difference.
there is.
Okay.
Think of it this way.
Okay.
White hydrants are the general workhorses connected to the overall network,
I see.
while yellow hydrants have a more direct link to a specific main line.
Okay.
It might seem like a minor distinction,
All right.
but it can be important information for firefighters who need to know exactly where the water's coming from and how
Mhm.
much pressure they can expect.
Okay, that makes sense.
Yeah.
It's all about having the right information in an emergency situation.
Yes.
But what about those other colors I've seen, like red and violet?
Now, those are the real outliers.
Okay.
Red hydrants are reserved for special operations only.
Okay.
You might see them at airports, military bases, or industrial sites where there are unique safety protocols or the need for a specific type of water flow.
Okay, so red is like the VIP section of fire hydrants.
Exactly.
Access granted only to those in the know.
Yes.
And then there's the mysterious violet hydrant.
Yes.
This one is particularly interesting because it indicates that the water source is non-potable.
Yes.
In other words, don't drink from it.
Correct.
Wait, non-potable.
What?
What kind of water would that be, and why would a fire hydrant be connected to it?
Good question.
Yeah.
This water might come from a lake,
Okay.
a river,
Ah,
or even an industrial recycled water system.
Oh, wow.
It's often used for things like irrigation industrial processes or even fighting certain types of fires
I see.
where drinking water isn't essential.
Okay, so it's about having different water sources for different purposes.
Oh, it is?
Kind of like how we have separate pipes for our drinking water and our wastewater.
Precisely.
Yeah.
And using non-potable water for certain tasks helps conserve our precious drinking water resources.
Okay, so we've got a handle on the color coding system.
Good.
But I'm curious about those hydrants that are designed for colder climates.
Okay.
You know, the ones we talked about
That's
earlier that
helpful.
prevent freezing.
Yes.
How do those work exactly?
Yes, the dry barrel hydrants.
Okay.
These are quite ingenious, actually.
Well-
In areas where freezing temperatures are a concern, you can't have water sitting in the hydrant itself,
Right.
or it could freeze and burst the pipe.
Sure.
So they've come up with a clever solution.
Okay.
The main valve is buried below the frost line, keeping it safe from the cold.
So the water is stored underground where it stays warm enough not to freeze.
Correct.
But how do you access it if the valve is buried so deep?
That's where it gets really interesting.
Okay.
When a firefighter opens the valve at the top of the hydrant, it activates a long stem that reaches all the way down to that buried valve.
Wow.
It's like a long-distance lever
Okay.
that opens the gateway to the water supply.
So it's like a reverse periscope.
That's a great way to put it.
Instead of seeing up, it's reaching down to control the flow of water.
Yes.
That's fascinating.
Yeah, it's a testament to the ingenuity of engineering, finding solutions to seemingly simple problems.
And to think all of this is happening right beneath our feet every day.
It is.
It's amazing how we often take these systems for granted.
We do.
But let's be honest, most of us only really think about fire hydrants when we see those dramatic scenes of firefighters battling a blaze.
Yeah.
What goes into making sure those hydrants are actually ready to go when they're needed most?
That's where the unsung heroes of the water world come in.
Okay.
The inspectors.
Hmm.
They're the ones who meticulously check every hydrant,
Right.
to make sure they're in tip-top shape and ready to deliver that crucial water supply.
Okay, so inspector, I'm picturing someone with a clipboard and a wrench going from hydrant to hydrant.
Pretty much.
Right.
But it's much more than just a visual inspection.
All right.
These folks are trained to spot even the smallest signs of wear and tear, damage, or potential malfunctions.
I see.
They're like detectives searching for clues
Oh,
that could indicate a problem before it becomes a disaster.
so they're not just checking to see if the paint is chipping.
No, they're not.
Okay, what kind of things do they look for?
Well, they'll examine the hydrant's physical condition, looking for cracks, leaks, or any obstructions that could hinder its performance.
Uh-huh.
They pay close attention to the valve mechanism, ensuring it operates smoothly and seals tightly when closed.
Right, because a leaky valve could not only waste precious water, but also reduce the pressure available for fighting fires.
Exactly.
It's all about being proactive and catching those small issues before they turn into big problems.
It is.
Okay, so how often do these inspections happen?
Well,
Is it like a yearly checkup, or are we talking more frequent visits?
the frequency depends on a variety of factors, like the age of the hydrant,
Sure.
the local climate, and the overall condition of the water system.
Right.
But generally speaking, hydrants are inspected at least once a year,
Okay.
sometimes more often in areas with harsh weather conditions or high-risk zones.
So they're getting regular checkups to make sure everything is in order.
They are.
But what about testing the actual water flow?
Okay,
Do they really open up each hydrant and let the water gush out?
absolutely.
Really?
It's not just about looking the part, it's about making sure those hydrants can actually deliver the goods when they're called upon.
Wow.
So inspectors will attach a pressure gauge to the hydrant
Okay.
and actually test the flow of water.
I bet that's a sight to see.
It can be.
Yeah, that guys are erupting from the sidewalk.
Yeah.
But seriously, what are they looking for when they do these flow tests?
Okay.
Is it just about making sure the water comes out, or is there more to it?
There's a lot more to it than you might think.
Okay.
They're checking everything from the valve functionality
Uh-huh.
to the pressure in the pipes.
Okay. Before and during the flow,
Right.
they're looking for any signs of pressure drops
Okay.
that could indicate a problem with the water main or the hydrant itself.
So it's about making sure the water pressure is consistent and strong enough to effectively fight a fire.
Exactly.
Oh.
Remember, those fire hoses need a lot of pressure to reach those high flames and deliver enough water to put them out.
Makes sense.
Wow.
Okay, so we've covered the basics,
All right.
how fire hydrants work,
Yep.
the color coding system,
Uh-huh.
and the importance of regular inspections.
Okay.
But you mentioned earlier that there are two main types of fire hydrants in the U.S.
Yes.
We've talked about those dry barrel hydrants,
Right.
but what about the other type?
Yes. You're referring to the wet barrel hydrants.
Okay.
These are the workhorses you'll typically find in areas with milder climates,
Okay.
where freezing isn't a concern.
Right.
Think California or Florida.
Gotcha.
Mm.
So no need for those fancy underground valves in those sunny states.
Nope.
What makes wet barrel hydrants different? Well, with wet barrel hydrants, the entire barrel of the hydrant is filled with water all the time.
Oh, really?
Yes. The valve that controls the flow is located above ground,
Okay.
making them easier to access and maintain.
So it's a simpler design, basically, just a pipe filled with water and a valve to release it.
Pretty much.
Okay.
But don't let the simplicity fool you.
Right.
Wet barrel hydrants are still incredibly effective and play a crucial role in fire protection in those warmer climates.
It's amazing how something as seemingly simple as a fire hydrant can have so many variations and complexities.
That's the beauty of engineering, isn't it?
Yeah.
Finding solutions that are tailored to specific environments and challenges.
Speaking of challenges, you mentioned earlier that testing those fire hydrants can sometimes cause pressure drops in the water system.
Yes,
That sounds potentially problematic.
it can be.
Can you elaborate on why that happens and what the consequences might be?
Certainly, when a fire hydrant is opened and water starts flowing, it can create a sudden demand on the water supply in that area.
Okay.
This can lead to a temporary drop in water pressure,
Hmm.
especially if the water mains are older or not designed to handle such a large volume of flow.
So it's like sucking all the air out of a balloon.
That's a great analogy.
Okay.
And while a slight pressure drop might not be noticeable in most cases, it can have more serious consequences in certain situations.
Like what? Give us the worst case scenario.
Well, imagine a hospital operating room or a factory that relies on a constant and precise water supply.
Okay.
A sudden pressure drop could disrupt those delicate processes
All right.
and have serious repercussions.
Yikes. That's not a risky one to take.
Yeah.
So how do they prevent those drastic pressure drops from happening during hydrant testing?
Well, the inspectors are trained to monitor the pressure carefully during those tests,
Okay.
and they can adjust the flow accordingly to minimize any negative impacts.
So it's a controlled release, not just letting the water flow freely.
Exactly.
Okay.
And in some cases, they might even notify nearby residents or businesses in advance if they anticipate a potential pressure drop.
That's good to know. It's reassuring to know that they're taking precautions to minimize any disruptions. But what about those times when the pressure drops significantly, either during testing or an actual fire situation? I've heard about boil water advisories being issued.
Yeah.
What's that all about?
Ah, yes, the dreaded boil water advisory.
Okay.
It's not something anyone wants to hear, but it's an important safety measure that's put in place when the integrity of the water system is compromised.
Okay, so walk us through it. What causes a boil water advisory, and why is it so important to heed those warnings?
Well, as we discussed, a sudden drop in water pressure can create a vacuum in the pipes.
Right.
And this vacuum can actually suck in contaminants
Oh.
from the surrounding soil or groundwater back into the water supply.
Ew, so we're talking about dirt bacteria and who knows what else getting mixed in with our drinking water.
Not exactly a recipe for a refreshing drink.
Right.
And these contaminants could include harmful bacteria, viruses, or other substances that can make people sick if ingested.
That sounds pretty serious.
Yeah.
So what's the solution? How do you make the water safe again?
That's where the boiling comes in.
Yeah.
Boiling the water for a specific amount of time, usually 1 minute at a rolling boil,
Okay.
kills those harmful microbes and makes the water safe to drink again.
Oh, wow.
It's a simple but effective way to protect public health when the water system is compromised.
So it's not just about the inconvenience of boiling water. It's about safeguarding our health and preventing the spread of waterborne illnesses.
It is.
Okay, I'm definitely going to take those boil water advisories seriously from now on.
Good.
This has been incredibly insightful. Who knew there was so much to learn about fire hydrants? It's amazing how these seemingly simple objects we pass every day are actually such vital pieces of our infrastructure and play such a crucial role in public safety.
It is amazing, and it's a testament to the ingenuity of engineering and the dedication of the people who work behind the scenes to keep these systems functioning properly.
And to think we've only just scratched the surface.
We have.
We've got a whole lot more to explore in part 2 of our deep dive into the fascinating world of fire hydrants. So don't go anywhere.
We'll be right back after a short break. Welcome back to our deep dive into the world of fire hydrants. We've already covered a lot of ground, but there's still so much more to explore.
Okay.
I'm particularly excited to delve into the history